Hello, everyone. So we are back continuing talking about philosophy and medicine to go along with the other scientific stuff that we talked about in the Renaissance here. And I think my writing here puts it pretty succinctly. We're doing a lot more thinking and less dying, and you can't beat that. So we're going to open up with a guy by the name of René Descartes. He is rather important for a variety of things. He's a philosopher and a mathematician. He did a lot of different stuff. Mathematic-wise, he is most known for the Cartesian coordinate system, which, as you mostly are juniors or seniors, you've come into contact with this. If you see on the right, describes the position of a point in two dimensions by giving it horizontal and vertical locations. That stuff is all pretty self-explanatory at this point. That's stuff that you've come into contact with. He also was able to develop analytical geometry, which has been used in a variety of different practical applications. Most notably, it's used by like NASA to send people up and bring them back, and satellites and all that fun stuff. It is fairly important. Now, that's going to be his practical impact. But as we go on, you're going to see he had a lot of impact philosophically as well. He was very highly educated. He actually also served in the army as well during the 30 Years' War. He really is going to be, I guess you could say, one of the main thinkers of the Renaissance. And what really hits him is he's working on his math and he's working on studies, and one night, and it all kind of comes together for him in 1619. And what it all comes down to is this idea of doubt. What really started to happen is he started to doubt everything that was taught to him, okay, because of falsehoods he found in a lot of it. And what started to happen is that because he studied a lot and found issues in like Aristotle and groups like that, he immediately began to start to doubt like everything in the universe, including his existence. But while he was doing that, he's going to go in a different direction, which this idea of reason. And here's a quote from him. So remember, at this point, he had gotten to the point where he's starting to doubt all existence. And then we go to, but I immediately became aware that while I was thus disposed to think that all was false, it was absolutely necessary that I, who was thus thought, should be something and nothing, that this truth, I think, therefore I am, was so steadfast and so assured that the supposition of the skeptics, to whatever extreme they might be carried, could not avail to shake it. I concluded that I might, without scruple, accept it as being the first principle of the philosophy that I was seeking. Thus, the fact that he becomes focused on reason. I think, therefore I am. If you can reason something out, it exists. If you can't, well, then there's a problem. And what that results in is this idea of Cartesian dualism, okay? And what ends up happening here is that the mind, okay, is what drives everything. And the mind itself is actually separate from our physical body, okay? It allows us greater understanding. It allows us to reason things out. And that actually, and the main tool that supports that is mathematics, hence why all his work in analytical geometry, Cartesian coordinate systems, stuff like that. And he also has the idea that the physical world was actually created by God, and we use math to figure it out. And this is the idea of the development of rationalism, okay? And again, we've talked about this before, this idea that people, religion and science can't go together, and Newton kind of did, and René Descartes will do that as well. This idea that we live in this world that was created by God. God gave us this mind to reason these things out. And as a result, he develops with this dualism, okay, the mind is separate from the body, and that's what allows us to understand what exists out there. This idea of the Cartesian method, okay? And the idea here is that each step in a scientific argument should be based on some mathematical proof. That's why when you guys took geometry, you did all those mathematical proofs. And so you can blame him or Euclid, pick one. And using math, you could discover basic axioms that could be used to discover deeper and more complex truths. And that's really, really important. So here we have a really structured approach. He's going to influence tons of scientists after him and other thinkers and philosophers. And so here this guy has this kind of abstract thought, the idea of, I think, before, therefore I am, very matrixy type things, if you will. But at the same time believes in the concrete importance of mathematics. Another big guy at this time that had huge influence was Francis Bacon. He's a pretty interesting guy. I mean, he was a lawyer. At one point became a lord in England. Although I have him as an interesting guy as well because he had some issues, is that he rejected Copernicus, Kepler, and he didn't necessarily like Galileo either. Now, Bacon's going to have some thoughts on science, which are going to be really important. It's just that he didn't necessarily believe a lot of the science that was coming out at the time, and that's okay. On a side note, he helped to found the Virginia colony, so there's that. So, what his works were all about? Probably one of his more important works that he actually never finished was the Great Instauration. And what he wanted to do is to, quote, commence a total reconstruction of sciences, arts, and all human knowledge raised upon the proper foundations. So he basically said that we have the ability to understand the natural world, but we've been going about it the wrong way. Okay? And as a result, the foundation of our scholarship is wrong, because the idea in the past is that everything we're doing, we're just focusing on like observation or focusing a little bit too much on religion. And so what he's going to develop out of this is the scientific method, or the Novum Organum. And this is really huge, okay? This is the basic idea, is that you proceed from a particular or a small-scale fact, and that will lead you up to more general truths, okay? He's really big on practical results. He's not much of a theorist of anything, He would be the guy that would take the ideas of, like, say, Einstein or Stephen Hawking or guys like that, and then figure out a test to see if those were actually true. Okay, and the idea that you've done in labs and stuff like that is that you come up with a hypothesis, you test it through intense experimentation, you catalog all the results, and then you figure out and share the conclusion. And this, was huge. I mean, for him, his goal, if you will, was to, again, inherently allow humans to, like, conquer and control nature through science, but this set up basically kind of how we go about theory development and proving those theories today. So between Descartes with his focus on mathematics and reason, and then the scientific method developed by Bacon, you can see why so many scientists would be influenced. And it wasn't just scientists. We also really had some good things with health as well. And again, just eat a vegetable. Like one. Can you at least eat one, please? All right. So some guys that really made some big changes here. The first one here is this guy by the name of Paracelsus. You see him with his little notebook there. That's going to be important. He traveled all over the world. We think he might have gotten a degree from the University of Ferrara in Italy, although we're not 100% sure. He wasn't really nice. He didn't work well with others who disagreed with him. He was one of those, like, he is a genius, but he's also kind of a jerk. So he really doesn't have a lot of jobs that work real well. So he's going to work on his own. The big thing for him is that his rejection of the past, just like many of the other guys, the big guys that wrote a lot on health prior to him during the Greek era, where like guys like Aristotle and Galen, and he's like, these guys are wrong, and this just, no, we need to figure this out. And he's also not a big fan of universities, because at that time he still thought universities were focusing too much on the past and not doing like research and pushing the boundaries. So what does he come up with? Well, probably his big thing is a microcosm slash macrocosm theory, which basically is that a human is part of really the greater universe, and that all parts of the universe are actually represented within the human body. That is actually remarkably correct, and we'll kind of talk about that later, and we can get to it in class. And one of the ideas of that, if you look on the right, you see a computerized version of a brain cell, okay, and that's on the left. And on the right is a representation of a galaxy cluster, and you can see they're remarkably similar. And we'll talk. I want to talk about that in class because it's really, really fascinating. He also goes on to theory that aside from the body being part of the greater universe, that chemical reactions of the universe are also reproduced in human beings on a smaller scale, and we're going to really start to pick it up with chemistry as we move on into the 1700s. And diseases were not caused by an imbalance of four humors, but chemical imbalances in your body in specific organs, and thus they could be treated with chemical remedies or medicine. All right, and that's going to also prove to be very, very right. Remember, we don't have any germ theory till Louis Pasteur, and that's in the 1800s. Okay, and he's really big on pharmacy, okay? And a lot of us today think pharmacists just put pills in a bottle. They don't do that. They do much, much more. The big thing is you pay meticulous attention to detail to make sure what you're putting into it. You want to catalog your dosages that you use. They actually understood the concept of overdosing at this point. He did like to experiment with that, though, and sometimes he would actually use some things that were toxic, but in low doses, he would have some success. But this is what a lot of people didn't like about him, that he was willing to almost kill a patient to figure stuff out, and you're not really supposed to do that, and we'll get into that as we move on as well. And most of us look at him today as the father of modern medicine, as well as things like the founder of holistic or homeopathic medicine, of using things in the natural world to treat diseases. And so he was pretty important. All right, another guy that comes out is Andreas Vesalius. He's going to study medicine in Paris and actually become a surgeon. And his big influence was a book on the fabric of the human body. This is a book of anatomy that was based on actual dissections of humans, which again typically is seen as illegal, or the church wouldn't let it happen. But because of some changes, of course, due to the Protestant Reformation and stuff like that, these guys were actually getting more opportunities to do that. And that's going to be really, really important. And he has careful examination of individual organs and the structure of the body. You can see a page from his book on the fabric of the human body. And this is going to be huge in that he's going to influence people in a lot of different ways. One, medicine-wise, what he will discover would be the fact that arteries originate from the heart, not the liver, which is what Galen and other previous physicians thought, and that's going to be a big deal for the next guy who comes up, because he's going to be able to take that idea and run with it. But he's also going to be really influential in Renaissance art. Remember, Renaissance art and architecture were looking on making things like real, and so a lot of these guys would study anatomy and anatomy books when they finally come out, so that it can allow them better representation of a real human form. All right, and the guy we're going to end with here is the titan of all medicine, William Harvey. And we keep it pretty simple. William Harvey figured out the circulatory system in 1628. The basic function of how the entire human body works. Oxygen comes in through the lungs. Blood is pumped by the heart. It is spread throughout the body. His work is 100% confirmed in the 1660s because we start to have the development of microscopes, and that allows people to see capillaries, which were these little small things that move the blood back and forth that you can't necessarily see with the naked eye. And Harvey theorized these, but it needed to be proved later on. This is huge because it's the foundation of modern physiology and biology, and allows us to treat diseases more. And so what we can see is that we're figuring out the human body. We're figuring out how to treat it. We're trying to figure out these ideas of medicine, okay? We're not relying on just religion or superstition and stuff like that. And so it's tremendously different, and we're going to really see some big changes, okay? All right, make sure you guys finish up your assignment. I'll see you soon.